problem is a word problem, and it's something you might see on an exam or a practice problem or homework. And it's a little more in-depth than just a straightforward predict the product practice. So this question asks us, the compound cis-1-chloro-3-methylcyclohexane undergoes an E2 reaction. That's elimination bimolecular, one step. That is about 1,000th as fast as the corresponding trans isomer. So it's trans isomer react 1,000 times faster. Both isomers give the same two products using well-drawn conformations. That's our hint. The two compounds explain the difference in the reaction rate and draw the two products. So I have both the cis and trans conformations right here. Let's start by drawing that product. So they both give the same product. Let's see if I can still draw a chair conformation. I'm not terribly great at them. I know some people used to use those little cutout tracers. I was always stubborn and never did that. So now we're going to draw the CH3 on a little squiggle bond to show that it could be either up or down. And then we're going to have our double bond either here or here, because it could go either way. But now remember, in an E2 reaction, we have our substrate, which is this chlorine right here. That's our leaving group. And we need to have hydrogen that is beta to it. And that is 180 degrees away from it. So we have that in both of these. So we're gonna have our strong base, and it's either gonna come and grab this or this and give us one of these isomers. However, why does this cis one react 1,000 times slower than this one? Well, you see here in the cis, they're both axial up, which creates this 1,3 diaxial interaction right here between these two, which strains the ring and makes this unstable conformation. So this is actually quite unstable, though it is its reactive form. What the ring is then going to want to do is actually ring flip, where you draw it backwards now. Not backwards, but I think I did this right. It's going to ring flip, and then what you're going to have is where it is axial down. I'm sorry, they're both axial. Or not axial anymore, I'm sorry. They will both be equatorial. We have our CH3 here. And we're going to have, where is it? This is our position now. We're going to have our chlorine here. They're still up. They're still both cis to each other. However, now they're in the diequatorial form, which is much more stable because we removed that 1,3 diaxial interaction. However, this is an unreactive form because this is not in the axial position where it can then undergo the E2 elimination. So the form that it prefers to exist in is non-reactive. So only rarely when it doesn't exist in this form is when it will react. This one, however, has no 1,3 diaxial interactions, much more stable, and is readily reacting. So this is why the can reacts that much faster. It's 1,000 times faster.